Today's Daily Dose of Math is for the Math 3053 Geometry course. In this situation, we are being asked to make a scale diagram. But in this video, I'm not going to show the making of the diagram because we have to do some steps with our geometry before we can start the diagram. Let's look at the situation. We're planning to make a cake with 3 layers, 2 of which are similar cylinders and the third of which is a cube. We have a diagram of the cake over here. I need to draw a scale diagram for the customer, and I know most of the dimensions which are given here in green. But I can't complete my diagram until I figure out the height of the larger cylinder, which is not given. I do know that the ratio of the volumes of the 2 cylinders is 27:1. Now there's more than one way of working our way through this problem. Here's one solution. I take the volume of a cylinder formula, and I plug in the 3 centimeter radius and the 10 centimeter height from the smaller cylinder. I'm able to calculate the volume of the smaller cylinder, which is 90 pi. Yes, I could multiply 90 by 3.14 or by 3.1416 or by the exact value of pi in my calculator. But I'm going to avoid rounding and I'm going to avoid turning pi into a decimal for now. And I'll show you why. The next step, since we know 90 pi is the volume of the smaller cylinder, is we can make a proportion. Using the ratio of the volumes, we plug in the volume of the smaller cylinder. It will go on the bottom because I have my 27:1 arranged so that the larger volume is on the top. Cross multiplying, I get 2430 pi as the value for the volume of the larger cylinder. Well, I can plug that into that same volume of a cylinder formula and plug in the 9 centimeter radius. Now I'm solving for the height. I end up with the height is equal to 2430 pi over 9 squared times pi. And then I can cancel the pi's. This is why I avoided putting in a decimal version of pi earlier in the problem. Some of these problems allow you to cancel pi so that you can keep more exactness in your answer without having to put in decimals and round off. My height of the larger cylinder ends up being 30 centimeters. Now there is another way through this problem. We can find the cube root of the ratio of the volumes, which gives 3, which means 3:1. That's the ratio of the distances, like the radiuses and the heights in the cylinders. And then I multiply my 10 centimeter height of the smaller cylinder by that 3, and I calculate that the height of the larger one is 30 centimeters. The same answer I got over here. Seems a lot simpler, doesn't it? Well, a student who really understands the relationships that are taught in this geometry course understands that they can do this sometimes. Either way, we have solved for the missing height, and we can go on and make our scale diagram an accurate scale diagram. Now, if you get a large question in the exam for this course that works something like this, I can tell you from experience that a lot of my students see this sort of situation and they just want to rush and draw the scale diagram. They try to pretend that it doesn't matter that they don't know this height. But those students, when I grade them, their mark is going to crash because this is a necessary step. Whether you do it the longer way or the shorter way, it's a necessary step to find the missing height before you can do a proper scale diagram. Therefore, it is an important part of the process. And when you think about it, using the volume of a cylinder formula is not really that difficult. It's something that you've been practicing if you've been working on this book. It's important to me when I'm correcting that a student at least is trying to find the missing height, instead of pretending that it doesn't matter. It will make a big difference in their overall grade, and it will make their drawing better. That is today's Daily Dose of Math. Please like, subscribe, and share.